I'm Jacqueline Isaacs, also known as the Unsmug Mum, and jacquelineisaacs.co.uk, and today we are going to start to delve into the subject of carb sugar, which is, here's my high-tech props, glucose. And in one of my previous videos, we talked about glucose being a monosaccharide, mono being meaning one, saccharide meaning sugar. One sugar is one sugar molecule. It is a simple sugar. At this stage, just to mention, glucose, our body and our brain love glucose. So G for glucose can mean great, we love glucose, and gimme, gimme, gimme. The body wants it. Every single cell in our body can use it. The brain prefers it. The body could potentially break down fat for energy, as we know. But in terms of the brain prefers glucose, which is why if you go on a low-carb diet, you might end up with a bit of brain fog or at least a headache or two, because the brain prefers glucose. So when our blood sugar is low, we might get a bit headachy and a bit fuzzy. Okay, so carb sugar. Carb sugar largely comes from starch. So let's understand with another high-tech, brand new high-tech prop, a little bit about starch. What is the difference between glucose and starch? Well, can we begin to see? Glucose was a monosaccharide. Starch is a polysaccharide. Poly meaning many, saccharide meaning sugar. Starch is a polysaccharide. Starch is many sugars. Okay, so we often hear people going on about low-carb diets being the way to lose weight. Just for the record, I am not anti-carb, but we do need to be a bit clued up about our carbs, and this is where we start. So, starch is made up of many glucose sugars, yeah? So we see here, we've got lots of the glucose sugars, all holding hands. You see that? All holding hands. Okay, so this seems quite big, a lot bigger than just one single simple sugar on its own. So does that mean that starch is any harder, does it take longer for our body to digest starch than if we were to consume it as a simple sugar in its monosaccharide form? Well, to understand that, I'm going to talk about spit. Do we know what spit is? I've got some interesting facts about spit. Spit is filtered blood. I didn't know that until quite recently. It was in one of my books that I read. Spit is filtered blood. Basically, spit is our blood with all the blood cells taken out, because obviously they're needed elsewhere. They're not really needed in our mouth, and that would look pretty gross. So spit is filtered blood. What is blood made of? Well, apart from all the red blood cell bits and pieces and all of that, it's a liquid, right? It's 92% water. All right, because obviously all of that stuff needs to be suspended in liquid form to move around our body. We know we're made of lots of water. Our blood is around about 92% water. So we can imagine our spit, by the time that's been filtered and had all the red blood cells and things taken out of it, that's mostly water. Okay, let's go back to our starch molecule. Holding hands, all holding hands, quite big. You know, when we think about, I've talked about before, our gut lining being a bit like a sieve or a plug hole. Now, if we think of those little holes in our gut lining being a little bit like hobbit doors, that this can whiz through, yeah, on its own. They're perfectly sized, there we go. It can whiz on through like a little hobbit door. This isn't going to fit through in that form, is it? So it needs to be digested, and they need to be broken apart. So we need to break their hands. How does that happen? Does our body have to work at it? Is it slower to digest than glucose on its own? Well, the process to break these holding hands, to make them let go of each other, is a process called hydrolysis. Ring any bells? Hydro, water. Okay, can we see where we're going with this and why I talked about what spit's made of? To break the bonds between each of these molecules only takes a little spot of hydrolysis. Water. That's all it takes. Really easy. Bish bash bosh. There's suddenly lots of simple sugars. Where does that digestion start to take place? Well, for comparison, let's think about fibre that I talked about in the last two videos, our hairy porridgey plug hole effect from fibre, and the fact that we do not digest fibre, that it goes all the way through, which is really great. We go in the mouth, through the stomach, through the 22-foot long intestines, all the way to our poo factory, which was great because we feel fuller for longer. It reaches the good guys in our poo factory, which is great, and it triggers the release of the peptide YY hormone, which is found at the end of the 22-foot long intestine. So obviously, if something we're eating has been fully digested in our intestines, it's not going to trigger the release of that appetite reducing hormone, which is why things that we do not digest, like fibre, are so important, because we really want our, especially if we're trying to manage or lose weight, we really want to trigger the release of that appetite reducing hormone. Does starch do that? Okay, well, let's go back to this bit of high tech. If it only takes water to break the bonds and make these little guys let go of each other and turn them into the simple sugar that whizzes through the holes in our gut lining, whizzes through the sieve as fast as water or sand through a sieve, where does the digestion of that starch begin to take place? Water, bit, mouth, yeah? If we took a piece of fluffy white bread, not the crusty bit, I'll explain about the difference between those two pieces of the bread soon, and why it was the mums of old going on about eat your crust, eat your crust. It's probably they were onto something. If we could take the fluffy white bit of the bread and held it in our mouth long enough, it would start to dissolve, right? It would start to go a bit mushy. Eventually, if we held it in our mouth long enough, it would break down into glucose, and it would start to taste vaguely sweet, because it only takes water, which our spit is mostly made of, to break the bonds between these little guys in starch, right? So if it happens that quickly, digestion of starch it's already happening in the mouth, let alone by the time it gets to the stomach, let alone by the time it gets to the intestines. Can we start to see how quickly starch is broken down and compare that to what happens with fibre and the difference between those two? So we can start to understand why it's going to be so important to understand where our sugar comes from, the differences between them, and the impacts on our body. You know, when we think about our refined carbs, like our white flours that are present in things like bread and cereals and pastas, if we think of anything that has had nature's packaging removed, because remember, I'm a big fan of old Mother Nature, and she wrapped her sugars in packaging. She put actual sucrose sugar, sweetie sugar, in a stick. She put fruit sugar surrounded by pith. She has put her carb sugar surrounded by indigestible husks of grain that that really make us chew. She's put potatoes in skins. You know, she has wrapped her sugars in the packaging that will help us to slow and impede it, the hairy porridgey plug hole effect. Yeah, us clever humans come along, take that packaging away. What are we left with? That. We've got none of the stuff that goes all the way through our system to the end and triggers the release of the appetite reducing hormone, feeds the good guys, etc. We're left with this, which whizzes through and is already broken down in our mouth. So that little bit of knowledge I'll build on in the next video. Hope we've learned some interesting facts there about our filtered blood spit. Have a good day.